you doing? You're gonna have to bear with me. I'm trying to figure this out. This is all new for me. You guys might be used to it if you've taken a virtual class before or something like that, but this is new to me, trying to figure out how to teach it. I hope you guys are doing well. I miss you all. It is weird teaching to an empty classroom. There's nobody in here, and so it's weird kind of just like talking to myself a little bit. And then there's Amanda. She said she missed you guys. I know, it's weird, but she said she did. So anyway, we're going to pick up where we left off with chapter 15. You guys, some of you have taken down some of these notes, some of you haven't. So what I'm going to do is I'm going to talk through them. And as I talk through them, you can get them down. If you don't have them, I would encourage you guys to write these notes down, even though we're not going to be in class for at least the next 2 weeks. When we do come back, I will be checking your notebooks, and I will be giving you a grade, a quiz grade, based on whether or not you have all of your notes. So I would encourage you, if you don't have these down, to get them down. And the goal is to hopefully wrap this chapter up by the end of the week. So you should have all of chapter 15 notes by the end of the week. So anyway, we were talking about acids and bases with this chapter. If you guys can think back with me, you might remember. Talking about acids and bases, and we have learned a whole bunch of things about them, why they're acidic, why they're basic. But now we're going to look at the main way that people tell whether something is an acid or a base, or if it's neutral. And that is by looking at the pH of a substance, okay? So pH has to do with the ability of a substance to create ions, pretty much. So we're going to look at the ionization of water, because water has the ability to be a pure substance. So we're going to use water as our base pure substance in reference to everything with pH, all right? So you have the ionization of water here. The equilibrium constant for water is also known as the ion product constant of water, and that is represented here, you can see, with Kw, okay? And that Kw basically just tells how much ability does it have to make ions, okay? So it's expressed mathematically as Kw is equal to H3O positive times OH negative. So what that means is the ability of a substance to make ions has to do with how much acid is naturally present in that substance and how much base is naturally present in that substance, all right? So in pure water at 25 degrees Celsius, the acid and the base are equal to 1.00 times 10 to the negative 7th moles. This means that Kw is equal to 1.00 times 10 to the negative 14th. All right, we get the 14 here because H3O positive is equal to 1.00 times 10 to the negative 7th. And OH negative is equal to 1.00 times 10 to the negative 7th. So you put both of those together to get the Kw equals 1.00 times 10 to the 14th. We get the 14 from 7 being from both the acid and the base there. All right, acidic and basic solutions. Neutral solutions, these are solutions in which the concentrations of H3O positive and OH negative ions are equal. So basically, there's an equal amount of acid ions, there's an equal amount of base ions present in that neutral solution. Acidic solutions, these are solutions where H3O positive or hydronium ions are predominant, okay? So that means that when a substance is acidic, that means that you will have more hydronium ions present. You will have more ability for an acid to be created, more acid ions to be created there. Same thing with a basic solution, except instead of hydronium ions, you're dealing with hydroxide ions, all right? So a basic solution there is a solution where OH negative or hydroxide ions are predominant. So when you're looking at the pH of a substance. Basically, you're trying to figure out which is more predominant. Do I have more hydronium? Do I have more hydroxide? All right. And the numbers of the pH scale indicate what you're dealing with. Are you dealing with more hydronium or are you dealing with more hydroxide? So the pH and the POH scales. You don't hear a whole lot about the POH scale because most of the time people just work with the pH scale, but we are going to talk about both of them. The pH scale is used to represent the amount of H3O positive ions in a solution. So the pH scale, this is important to remember, the pH scale deals solely with how many hydronium ions are there, okay? How much ability does this substance have the ability to make an acid, okay? That's what the pH scale looks at for every single substance on the face of the planet. How much ability does it have to make an acid? Okay, so the scale is based on numbers 0 to 14. Anything with a pH of 7 is considered to be neutral. It's the dead center of the scale. It is considered the neutral portion of the scale. Pure water has a pH of 7 at 25 degrees Celsius, and that's just the starting point. That's the working point for everything on the scale. Solutions with a pH of less than 7 are said to be acidic. Okay, the lower the pH, the more acidic a solution is. So you would think that something with a pH of 6 is actually very acidic. In reality, it's actually the opposite. Something with a pH of 6 doesn't have a lot of acid in it, versus something with a pH of 1, there's a ton of acid in that substance and you want to stay away from it. Solutions with a pH of more than 7 are basic, and the higher up you go, the more basic the substance gets. All right, now this should be new information. If I remember correctly, you guys have pretty much taken notes up to that point. So from here on out, it should be new information for you. And we will go through this. I would highly recommend to you to look up Khan Academy on YouTube. All right, look up Khan Academy and look up their information on logarithms. It's very helpful. It's very well done. I even use it to review every year to make sure that I understand how logarithms work. So I would highly recommend to you Khan Academy. That's going to help you be able to understand logarithms a little bit better if you don't understand it off of this. And that's fine if you don't understand it off of this. That's why there are other sources that we can go to, because Ms. Maxwell is not perfect. All right, so the pH of a solution is defined as the negative logarithm of the hydronium ion molarity, or pH is equal to negative logarithm H3 times H3O positive there. Now, a logarithm is just another way to express a number as a power of 10. Excuse me. Like I said, it's just another way to express a number as a power of 10. And I have two examples here for you. These are the easy logarithms, okay? If you know your powers of 10 well, and know how that works, then logarithm shouldn't be a problem for you. If you struggle with that, again, go to that Khan Academy video. It's going to be helpful to you. But an example here, 1,000 is 10 to the third, all right? We know that. The zeros are each representative. Oh, go back. There we go. The zeros are each representative of a power of 10. So 1,000 is equal to 10 to the third power, all right? And that's easy enough. You count the zeros, you count the spaces after the first non-zero digit. If you think all the way back to the beginning of the school year when we talked about significant figures and non-zero digits and all of that. With logarithm, you're going to start after the first non-zero digit, and you're going to count the spaces after that. That will give you your power of 10. So 1,000 has 3 zeros, so it's 10 to the third. The logarithm of 1,000 is 3, or log 1,000 is equal to 3. If you were to get your scientific calculator out get your scientific calculator out, you should be able to see, I'll bring it up here, maybe you can see on mine a little bit. You have two buttons here, you have log and you have ln, okay? So if you're trying to find the logarithm of a number, what you can do is you can press log 1000, close that in with the parentheses, and press equals, and I don't know if you can see it on my calculator or not, but you get 3, all right? Now, let's say that you're trying to find the logarithm of this decimal point down here, all right? Oop, wrong thing, sorry. Give me a second. All right, so example number 2, same thing with the logarithm. You're going to, on your scientific calculator, you can press log 0.01, close it in parentheses, all right, and press equals, and if you notice there, you get -2. If you don't want to use the calculator, you don't have to. You can do this out very easily. And the main reason this is negative is because you're dealing with a decimal point, all right? So you have the decimal point there. That means that you're dealing with a negative logarithm. Pretty basic introduction to logarithms there. You can get a lot more involved, you can get a lot more deep. Again, look at those Khan Academy videos. They have a lot of stuff on it, and they explain it a whole lot better than I do, guys. I'm just going to be honest with you. So I would encourage you to look at those videos. But logarithm is another way to tell if something is an acid or a base, okay? Because it shows you the amount of hydronium ion in the substance, okay? To find the pH of a solution, find the logarithm of the hydronium ion in the solution and change the sign, okay? If you are dealing with a positive, you're gonna wind up dealing, if you're dealing with a negative, you're gonna wind up dealing with a positive, and vice versa. All right, the POH scale. Now this is that scale that I told you guys. People don't really refer to it a whole lot. We don't ever really talk about it until you get to chemistry class, all right? And the POH scale expresses the concentration of OH, or the hydroxide ions, in a solution. So basically the POH scale looks at how much of a base is present in the substance. What is the natural tendency of this substance to turn into a base? Like I said, we tend to look at the ability of substances to naturally become acids with the pH scale. We're familiar with that. You can measure the pH of soil, you can measure the pH of milk, you can measure the pH of any substance really, but we don't talk about the POH scale very often. Now, it can be considered the negative logarithm of OH negative, or the hydroxide ion. In an aqueous solution at 25 degrees Celsius, the sum of pH and POH is 14. So, at 25 degrees Celsius in an aqueous solution, now remember, aqueous solutions deal with water, okay? Not just liquids, but water in particular. The sum of both pH and POH is considered 14, so you're dealing with a base. pH measurement. All right, a pH meter is something that they use nowadays, okay? So it's a great piece of technology. It has a little, what do I want to call it? A little, I guess, stick, for lack of a better term, on the end, and they can stick it into the substance, and that stick can then register to the meter if you're dealing with an acid or a base, okay? It is, here we go, I'll just read the definition. A pH meter is used to determine the pH of a solution by precisely measuring the electric current generated when a pair of electrodes are immersed in the solution to be tested. Now, most of the time we could get old school with acid-base indicators, okay? And these are organic acids or bases whose color changes with the pH of the solution. The one that you're probably most familiar with is litmus paper. Litmus paper, if it is a basic solution, the litmus paper will turn blue. If you're dealing with an acid, the litmus paper will turn red. Other indicators include bromocrystal purple. This is a neutral indicator that you can, if you guys were here, we would test it in the lab actually, because I have some in the lab. But it's a liquid that you can drop into the acid or base, swirl it around, and it'll change color based on whether or not you are dealing with an acid or a base. And phenolphthalein, same thing. You drop some into the solution, swirl it around a little bit, not shake, but just gently swirl it around a little bit, and it will change color depending on whether or not you're dealing with an acid or a base. And that is where we're going to stop for today. Just something fun for you to do if you are bored and you can convince your parents to take you to the grocery store. If you buy some purple cabbage, all right, you boil purple cabbage for a good 25-30 minutes, all right, boil it. The purple cabbage juice is a natural pH indicator, okay? So you can then take your cabbage juice and you can drop it into substances and do that little swirl test, and it will change color based on whether or not that substance is an acid or a base. Or if you want to make your own litmus paper, you can take some thicker cardstock, I would suggest white cardstock, and dip it in that cabbage juice after it's cooled. Don't do it while the cabbage juice is hot. Dip it in that cabbage juice, and it will allow it to dry, and then stick those pieces of paper into substances, and they will turn color based on whether or not you're dealing with an acid or a base. I hope this helps you guys at least get back on track with your notes. Like I said, you're going to need to take the notes every day, or every day that I put a video up, because we are going to be taking a quiz grade over whether or not you have taken your notes faithfully. And if you guys have any questions, shoot me an email, post it in the class forum on the RenWeb LMS, and we will pick up with acid-base titrations tomorrow or Thursday. Not really sure what day I'm going to do it at this point, but we will be finishing chapter 15 by the end of the week. All right? I'm praying for you guys. I love you. I miss you. Bye.